In this video, I want to look at sorting, specifically using a function to sort, which is something the documentation doesn't even tell you can do. If we look at the sort documentation, it shows an optional comparison criteria in the form of a list if you need to pass in 2 columns, and if you want to pass in an order also, that is to sort descending instead of ascending, then you can pass in a second list. But it doesn't show you can use a function, not even if we look at the examples. But it actually is possible. To start, I'll show the basic sort function. If we pass in TBL data, we can see that even though the function documentation said the second argument was optional, it actually isn't. If we say I want to sort based on the name column, since I'm only passing in one column, I don't have to pass it in as a list, but this will sort in an ascending fashion. And it will look at the first character and then the second character if there's a conflict. So here we have two names that start with F, but A comes before U, so fauna comes first. We can also do a 2-column sort. Here I'll use the language column since we have 3 unique values, Table.Sort on Table data. And then I have to pass in a list because I want to use 2 columns. And that wasn't called N, it was called language. Now we're sorting E comes before I and I comes before J. And in the case where we have duplicates in a language, we then sort on the name in ascending fashion. As mentioned, we can also pass in a function, which I'll start out by just doing a silly function. I'll start out by using a function that actually is the same as just passing in the name of the column. So we'll sort TBL data, and I want to then pass in each name. And this is the exact same thing as we did here, except I'm passing in a function instead of a column reference. And because we're using a function, that means we have access to the entire row, which lets us do things that are a bit different. For instance, I can do math, so maybe I want to sort based on the sum of 2 columns. This isn't something you can do in the standard sort, because it will first sort on the first column and then on the second if you have the same value. You can see here I have the same value in the number B column, 62 and 62. So if I just did Table.Sort first on the number B column, and then in case of a conflict we can do name. Now we have 62 at the bottom. Actually, let me use number C instead. But this isn't actually what I wanted to do. I wanted to do a sum of the 2 columns. And here we can use the function. We'll say each, I want to take the value in the number B column and add that to the number C column. And again, at base, this is sorted ascendingly, which means 7 plus 21 is less than 9 plus 32, and so on. If we want to change the sort order so it's in descending fashion, we have to pass in a list as I showed in the documentation. So I'll do Table.Sort. Then I want to pass in a list to use 2 columns. So say I want number B to be descending. I need to wrap that in quotation marks. Then we can say order descending. And then in case we have 2 of the same values, which we have here with 62, then I want to sort based on number C. Now we have 62 at the top because the order is descending. And then we have 41 first because the base is to sort in an ascending fashion. Lastly, if we wanted to do math like we do here, but we want to sort descending, we can't simply copy this and then add in this syntax with the list, because we'll be told that that isn't allowed. We want to wrap this in a list to say that was my calculation, and then I want to output order descending, but we get told we can't apply the operator less than to types list and list. And this is a bit of a hint to what we'll do in the next query, but one way to get around it is that in a normal ascending fashion, we have the value 1, then 2, and so on. But we can actually convert this calculation in the opposite order by simply saying 1 divided by, and then we wrap this in parentheses. Because now when you have a big number, 1 divided by a big number is a very small number, and 1 divided by a small number is not exactly a big number, but it's closer to 1. So B plus C is over 100, and 1 divided by 100 is then 0.01, so very small. And then 1 divided by 7 plus 21, that's 1 divided by about 30, and that's closer to 1. So this is a way to get around it, because what happens behind the scenes is that we use our function or the column reference, and then Power Query, in my understanding, turns that into a list, which is then sorted. So even though we're not adding a column, I think of it as adding a column behind the scenes. So a temporary column that's only used by Power Query to decide the sort order. So again, 1 divided by 62 plus 51, that is then a very small number. So when we have that invisible list of numbers to sort on, this row will end up at the top, because the output of this function is then the smallest value. And the base for Table.Sort is to sort ascending. We can now move on to the fancier sorting. In the first case, I instead want to sort based on the length of the name. And here we have to pass in a function, which we've shown that we actually can do. And this time my function is then going to be text length, and we're going to pass in the name column. We have 3 names that have a length of 4, meaning they are shown at the top, then the 3 names that have a length of 5, then the 2 names with a length of 6. But now we have a conflict because we have multiple names with the same length. So it's a bit random which shows up at the top and which is shown at the bottom. And another thing that the documentation doesn't show you is that actually you can pass in a 2-argument function. Here I'm passing in a 1-argument function. The way I think of it is that Table.Sort actually works the same way behind the scenes as Table.Group does, which is where it will take your current row and compare that to a comparison row, and then based on that calculation it decides the sort order. Again, it adds that invisible column, which is then used to create the sort order. We can actually copy the function, except that now instead of just saying text length of the current row, I want to say text length of the current row minus the text length of the comparison row. So I can replace the each with a comma b, which then goes towards. Here I then have to pass in a to say that this is the current row. Then I need to mind my parentheses. Then we're comparing to b. And nothing has changed except that the random sort for names that have the same length has changed a bit. What's happening behind the scenes, if we use this first row as the example, text.length of Gura is then 4, which is then minus the comparison row. Well, Risu is also 4, so 4 minus 4 is 0, but then 4 minus 5 is minus 1, and 4 minus 6 is minus 2. So we have 0, minus 1, and minus 2. So the 4-letter names end up at the top, because again, we get either 0, minus 1, or minus 2. Then we have the file length names, because 5 minus 4 is 1, and 5 minus 6 is minus 1. So this is in the middle. Again, the result is the same between the two functions here. I think this will help lay the groundwork for the next functions. What I want to do now is I want to decide how to sort if I have a name with the same length, because again, here it's random. I want to say I first want to do sort based on length, and if the two names have the same length, I want to look at the first letter. So we can copy this, and instead I want to save these in variables to make it a bit easier to follow along. So I want to say let compare equals next is equal to. If compare is equal to 0, then they are the same length. Then I want to do a comparison where I grab the first letter, which we can do with text start, to say I want to go into A and grab the first letter. Then I want to use text.upper. This isn't necessary, but I'll just do it to be thorough so we can make a general function. And then I want to convert that into the character, which is character to number. This is going to convert a capital A into the number 65 and a capital B into 66 and so on. So we can add that as a comment, but I then want to do the same thing to the comparison group, but then I have to write in B here, A equals 65 and so on. And a quick note here, this comparison will break if you have the Danish characters or the German characters in your text, because a Danish A is going to have a far higher value, so the comparison breaks. But again, this does the same comparison, and then in case compare isn't 0, then I want to output the compare value. Then I want to lastly break out of my let-in construction and output next. And then I need to not have a comma there. And here I forgot, I actually have to specify the column name. I want to go into the name column and grab that value. And now what we end up with is that we have a 2-tiered sort, where we first have the 4-letter names, then the 5-letter, and then the 6. And then in case we have the same length, we compare the two values based on the first letter. So G is less than R, and G is also less than S. So G is at the front. And then we have R compared to S, that's -1, but S compared to R is +1. And -1 is more negative, so Risu shows up before Sora. So this is actually what I want. Next, I want to do something even fancier, which is where I want to take my name and I want to convert the letters into their characters, as we did here, but I want to do it on the whole name. And then I want to sort based on the points of the whole name. I want to store that in a function to make it a tiny bit easier to follow along. Meaning my function is going to take an input of a text, and that's then going to go towards. I first want to convert the text into a list, which we can do conveniently with the text to list function, because a text is actually just a list where each item in the list is in a text character. Now we have that as a list. Then I want to do list transform. Actually, I need a name. I want to do list transform over my text. My transformation is then to use the character to number function, but I first have to convert the letters into the capitals, because a capital G is a smaller number than a small g. We then say text upper. I need to write the function here, the each. And then I want to say -64, because a capital A has the value 65, and this is just to make it a bit easier. This isn't necessary, but I just think it makes it easier to follow along. So A is now equal to 1, and C equal to 3, and so on. And then I need my comma. And lastly, we now simply have to sum up all the values. Make a new variable called sum, using list sum on the 2 points list. And now we can apply that. So I should name that before I use it. Before using the function, I want to show the output to make it a bit easier to follow along. where I want to use my function upon the name column. And then that gives me an error because I need to do that calculation outside. Because text.upper is text and then character to number, that outputs a number. So I need to do -64 here. So that is fine. And we could also add the column and then sort on this new column, but this column is only for illustration purposes. I wouldn't want to use it in my real data set, which means I can now do a sort with my function. So Table.Sort, tbuild_data. My comparison is then a function where I want to use funct_text_to_points on the name column. And again, this is done in an ascending fashion. You can see that Kyla has 5 letters, but 2 of her letters are an A and 1 is an E, which is small. And Amelia has a long name, but again, she has 2 A's and an E, which is not that high. And surprisingly, we have 2 4-letter names that are all the way at the bottom, because they have an S, an O, and an R and an U, which are high points. And Fubuki is all the way at the bottom because she has 2 U's. Lastly, I want to do sort of a repeat of this step, and I want to first sort based on the length of the name, and then afterwards I want to sort based on the points. We can copy this function, since I only have to change this part, which is then going to reference the funct_text_to_points. So we still want to compare based on the length, and then here I can replace that, where I want to use funct_text_to_points, first on the A row, the name, then minus, then we use the B row. And now my comment is no longer correct. So again, this is exactly what we expect. First, we sort based on length and then based on points. So even though Gura, Sora, and Risu have high points, or at least higher than Kyla, because the name is shorter, they end up at the front. And that's actually everything I wanted to show. So you now know you can use a function to do your sort order, and you can even use a 2-argument function, which I assume works like Table.Sort, where it compares the current row to a comparison row. Then it creates that invisible column, and then behind the scenes it will compare the rows until it finds the correct order, which I'm sure is some very fancy programming. But